Okay, today we're going to continue our discussions on volume, but turning our attention today to the figures that only have one base, which would be the pyramids, instead of the prisms yesterday that had two bases. All right, now just like with prisms, we're going to have a generic formula to help us with the pyramids and the cones. However, we are still going to need to we're going to have a need to make adjustments to the formula according to the particular shape we are working on. It's not going to be quite as much of an adjustment as it was yesterday, but still a good bit of generic in the formula. Okay, but we do have a formula that goes along with it, volume of pyramids. The formula should look largely familiar to what you were working with yesterday. The only difference is we have a coefficient in the formula this time. We have 1/3 times big B times little h. Now, of course, big B, little h, that was the formula yesterday, but today we're only looking at 1/3 of the formula. Now, big B and little h stand for today the same things that they stood for yesterday. Big B is the area of your base, and little h is the height of the pyramid. Okay, so let's just jump right into it. It's nothing more than a formula. It's making the figures fit the formula. So here we're going to have a pentagonal pyramid, and we're going to see if we can't find the volume. Okay, so we have a volume question for a pyramid. This is one of those where we'll go, all right, it's a pyramid, it's a volume question. They give us the formula for finding the volume of a pyramid. So we'll go to our formula chart, we'll get this formula off the chart, we'll write it down on our paper. 1/3 big B, little h. Then we just go through the same series of questions that we went through yesterday. Okay, big B is the area of the base. In order to figure out the area of the base, we have to know what kind of a shape it is. Okay, so we'll figure out what kind of a shape it is and then figure out what formula goes along with that. Well, what kind of a shape do we have on the base? Yeah, we have a pentagon, okay? And we said that when we're dealing with these surface area and volume questions, when it is these special shapes like pentagons and hexagons and heptagons and stuff like that, that our bases will be regular. So more specifically, we have a regular pentagon, okay, on our base. And then we'll need to know, all right, how do you find the area of a regular pentagon? Yeah, very good. 1/2 times the apothem times the perimeter. And if it holds true, okay, we said in the beginning that this is one of those formulas that we're not real sure if they're going to give us this formula or not. It does show up on the formula chart sometimes, other times it does not. So I'm hoping that everybody will do like Ilsa did and get this formula memorized just in case it's not there and we do need it. 1/2 times the apothem times the perimeter. Okay, so let's see if we have the information that is needed to solve or to plug into this formula. We need to know the apothem. Did they provide it for us? Yes, they did. They provided us the apothem. Remember, apothem means shortest distance from the center point to the side, and that's where it goes directly over to the side. Okay, and we have that. They gave it to us 5. How about the perimeter of the figure? Did they provide us that? Yeah, they didn't provide it for us, but it should be simple enough. They did give us one of the side links, or one of the edges down around the base at 3 units, and if it's a regular pentagon, then it should be 3 units on all 5 of these sides. So that's going to be easy enough to find. The perimeter is going to be 15. Just plugging in numbers. We've got 5 times 15, and that's going to be 75. Half of that should be 37.5. Okay. So there it is, big B. Okay, not a difficult calculation, just plugging in our numbers. All right, that's going to bring us to H in the discussion, okay, the height of the pyramid. Now, I've got this triangle that I'm showing you here, but if you glance back at the figure, okay, you will see that the height is not provided. Okay, the height is an internal measurement from the base directly up to the vertex. Okay, it is not provided, but we can build a triangle using the height, which is missing, and the apothem and the slant height, was provided for us at 13. So pulling that triangle out of there, there's the height that was missing. There's your 5 on your apothem. There's your 13 on your slant height. Does anybody know what the missing height length is going to be without doing any math? 12? Exactly right. It will be 12. This is one of the Pythagorean triples. Okay, so it's a 5, 12, 13 triangle. And if you knew that, then great, good for you. If you did not know that, that's fine. You can still go through the math and you can work it out. So we got 5 squared plus the height squared equals 13 squared. Okay, what's 5 squared? 25. How about 13 squared? 169, exactly right. Okay, we don't need this 25 attached to our height squared, so we would subtract it to the other side. You'd get 169 minus 25 would leave you with 144. And then we do not want the height squared, we just want the height. So we'd get rid of the squared by taking the square root of both sides, and the square root of 144 does turn out being exactly 12. So if you remembered it's a 5, 12, 13, great. You probably saved yourself some work. If you could not remember it, okay, just got to go through the Pythagorean theorem. But we've got a height of 12, so now we know the overall height of the pyramid. So all we have to do is finish plugging into the formula. We had 1/3 big B little h. We had big B, I can't remember, I think it was 37.5 on the last screen. And then height is, we now discovered it's 12. So we're just plugging in numbers. And we've got 1/3 times 37.5 times 12. That looks like 150 to me. Let's see what we got there. Yeah, 150. Okay, and they did not give us any units of measurement, inches, centimeters, miles, whatever. Okay, but whatever the units would have been, they're third dimensional because volume is a third dimensional measurement. So 150 cubic units, cubic inches, cubic millimeters, whatever they are. Okay, so it should feel just like yesterday. It's just plugging in numbers into a formula. And the only thing they can really do to us is change up the figures that they give us, or possibly not provide us with as much information as we would like. But that's the way this is going to go. All right, well, let's see what we have here. It's a volume question. It is definitely a pyramid. They called it a pyramid, and of course we can look at the figure. One of the giveaways of a pyramid is, of course, it's only going to have one base. Another one is that it's going to be largely built out of triangles. So we got a lot of reasons to believe that this is a pyramid. So we've got a formula. We'll go to the formula chart. We'll get our formula. We'll write it down. The formula is 1/3 big B little h. All right, so we're going to roll through these variables, see if we can't figure them out. We need to figure out the area of the base. So, of course, we need to know what kind of a shape the base is so that we can get the right formula to calculate its area. Obviously, we're looking at a pyramid. Okay, so we're going to be looking at a triangular base. Okay, not only that, they even called it a triangular pyramid. So we know we have a triangle on the base. How do you find the area of a triangle? 1/2 times base times height. That's the straightforward formula. Some of you may have learned it as base times height divided by 2, and that's fine. Same stuff. Okay, 1/2 times base times height. Now, we're going to need to know the base and the height of the base. Okay. Well, this is going to cause us a little bit of a problem. Okay, let's get that triangle off of that base and have a look at it. We've got 4s on all of the sides of the triangle. Okay, and I put a height in there because that's a measurement we're going to need to know. And since the triangle is an isosceles triangle, when you draw in that height, that's actually an altitude. And an altitude is going to not only be an altitude, meaning it's going to form a right angle there with the base, which is good. That's what we need. But it's also going to be a median. Okay, so that's how come I took that 4 and I split it exactly into 2 2s. Okay. Now, based upon this information, we've got 2 sides of these little triangles. There's a little right triangle on the left, a little one on the right. We can do Pythagorean theorem. We can figure out what's going on with that height inside of there. Okay, we've got a 2 and an unknown height and a 4. This is not a Pythagorean triple of any kind. So we're going to have to work this thing out and see what number we end up with. Okay. On the left side, 2 squared. Obviously, it's going to be 4. On the right side, 4 squared be 16. Okay. Get this 4 away from our h squared by subtracting it to the other side. So you have 16 minus 4 over there on the right will leave you with 12. And then we don't want h squared. We want just h. So we take the square root of both sides to get the square off of the h. And we would have to take the square root of 12, and we're going to end up with a decimal point on that one because this is not a Pythagorean triple. Okay, so we've got something in the ballpark of 3.46 on the height of the triangle. Now, is this the value that we're looking for? Okay, did we solve for B? No, we haven't yet. What does this actually represent? This is the height of the base. We kind of detoured away from finding the area of the base because we were unable to plug in all of the information that we needed to into the area of a triangle formula. Okay, so now that we have this information about h, we need to come back to the area of the triangle formula from above and plug in to find out what we know about B. So here we're still trying to work on the area of the base. So 1/2 times base times height. Well, the base of our triangle, it was equilateral. We had 4s running all around it. Okay, so little b is a 4 there, and we just discovered that our height is in the ballpark of 3.46. Okay. Well, if those are the numbers, then when you run those numbers, it looks like you're probably going to end up with something around 7.92, 6.92, pardon me. Okay. There is big B. Okay, so is this the answer to our problem? No, we still haven't found the volume. This is a 3-step problem. We had to solve the height so that we could solve the area, and solve the area so that we can solve the volume. Okay, we still haven't figured out the height yet. Hopefully it's provided for us. Well, was it provided for us? Yeah, in this case it was. We don't have to solve the height. It was provided for us at 9. Okay, so that one was at least easy. We didn't have to stop and solve that. But now we finally have all the information that we need to solve for area. So back to the volume equals 1/3 big B little h formula. Big B we solved up above at 6.92. Little h was found from the problem itself at 9. Okay, so plugging that information in there. Okay, then we would probably most likely be in our calculator trying to figure out what's going on with that. Looks like 20.76 or something to that effect. There it is, 20.76. And again, they did not provide us with any units, but whatever the units are, they are going to be in the 3rd dimension because volume is a 3rd dimensional measurement. All right, can't get out of this discussion without looking at something that has circular bases. Said it before, and I'll keep on saying it, they do have a slight tendency towards asking questions on the figures that have circular bases. So here we have a cone. We're asked to find the volume. So let's see what we can do with it. Now, it really depends on the formula chart. Okay, some of the formula charts will come out and say under the volume section, they will say cone, and then they'll provide you with a formula that goes with it. Even if they do not provide you with the cone formula, simply remember that a cone is a type of a pyramid, and the pyramid formula will be on there. Okay, so I'm going to continue using the same formula that we've been using rather than any strange cone formula that they may come up with. Volume equals 1/3 big B little h. Okay, so just like always, we'll address the question, big B. We got to find the area of the base. So of course, same questions. What kind of a shape is the base? Circle. How do you find the area of a circle? Okay. Yeah, pi r squared. That'll be on the formula chart for you in case you happen to go brain dead and forget it. Okay. All you need to know to figure out that formula is the size of the radius. How big's the radius in this case? Yep, 25, so we'll plug it in there. So we're going to get 25 squared, which is 625, and then that's going to multiply times pi. So we're going to get a number approaching 2,000 on that. Okay, so we got a pretty big volume coming up on this one. We got 1963.50 just on the area of the base. Now from plugging into the formula, and we've done it a couple of times now, okay, we know we're going to have to know the height of the cone so we can plug into the formula. Do we have this value or do we need to solve for it or what? Yeah, they provided it for us. It's 90 in this particular case. So we seem to be home free. Okay, all we have to do is plug in the information that we have, 1/3 big B little h. On the previous screen, we decided that big B was 1963.50. The problem decided for us that the height was 90, so just plugging numbers in. And we've got a fairly ugly number coming our direction. 1/3 times 1963.50 times 90. That's a bunch. It's going to be up there just shy of around 60,000, I believe. Yeah. And we've got 58,905, whatever the units are, cubed. So whatever those units are, I hope they were really small, like millimeters. Otherwise, that's a gigantic cone. Okay, so that's pretty much it. All we need to do now is practice what we just learned. Use that formula, 1/3 area of the base times the height. That'll conclude the information that we have on volumes. We'll spend the next few days looking at cross sections and perspectives, and we'll be looking at a Unit 9 test sometime in the middle of next week.